Dear students, today we will talk about the streamline and turbulent flow of liquids. Now consider a liquid or some water or any fluid which is moving through some pipe. Okay, at different points the water molecules have different velocities. Say at point P1 it has a velocity V1, at point P2 they have a velocity V2, and so on. Now, if all the molecules of the fluid are moving with same velocity at different points, that is V1 is equal to V2 is equal to V3 is equal to some constant value V, then such a flow of a liquid will be called as a steady flow. Okay, and the path followed by the liquid will be called as streamline. It is also called a streamline or a steady flow of the liquid. Now, if the pipe or the tube through which this fluid is moving is straight, then the shape of this streamline will be straight. If it is curved like this, then the shape of this streamline will also be curved. But the only condition is that velocities at different points of flow should be same. All V1, V2, V3, Vn should be equal to some V. So that flow of liquid will be called as a streamline flow of liquid or a steady flow of a liquid. But all of us understand through our common observation that the flow of a liquid cannot always be steady, it cannot always be streamlined, and there is a certain value of velocity up to which the flow of liquid can be streamlined or steady, but after that it will be turbulent or violent or haphazard. Such a flow of liquid is called as a turbulent flow. Therefore there is some critical value of velocity up to which the liquid maintains the steady flow, and beyond which it is turbulent or haphazard, and it randomly follows any path. For example, if we want to explain that further, suppose I have a pipe, okay, and in this pipe I am able to pour water at one end like this end, and from another end I am trying to inject some ink or some colored liquid. I am injecting some ink or some colored liquid, because see, water is transparent, we are able to see through it, it doesn't have any color. So whenever the motion happens, yeah, turns from streamline to turbulent, we will not be able to judge that. A color will help us to identify that. Okay, a color will help us. That is why we are making use of some ink or some colored fluid. We will see that when the rate of flow of water from this end is steady, it is streamline, and we are also injecting this ink from the other end, this ink will be moving in the form of a band, parallel layers. But once we enhance the rate, enhance or increase the rate of flow of water, okay, from this end, we will see that there will be some whirlpools in the path of this ink also. It means at that point the flow of the liquid has turned from steady or streamlined to turbulent. Now the question is, how do we mathematically determine the value of this critical velocity? Because finally we have to parameterize it. We have to find some numerical value at which the flow will be streamlined and above which the flow will be haphazard or turbulent. Now that I have calculated on the next page, I have written that how do we determine the value of critical velocity. We are denoting the critical velocity with Vc, and obviously any student, any person can say that it should depend on three things. One is the coefficient of viscosity of the liquid, obviously, that all of you are aware about. Then density of liquid, it will depend on that also. It will also depend on the radius of the tube or the pipe through which the liquid is flowing, right? Now let us combine all the three factors. So it will be neta raised to power a. This critical velocity will depend on neta raised to power some a, rho raised to power some b, and r raised to power c. Again I am repeating that neta is coefficient of viscosity of liquid, rho is the density of liquid, and r is the radius of the pipe or the tube through which this fluid is flowing. Now taking this proportionality into equality, we will introduce a constant, and that is k, right? Now I hope that all of you are aware about these dimensional formula in your class 11th or 12th. So coefficient of viscosity neta will be represented by this m1 l minus 1 t raised power minus 1. So rho, which is the density of liquid, will obviously be given by m raised power 1, l raised power minus 3, and r, which is simply the length or the radius of the tube, it will be given by L. Once we combine all the three and we equate the coefficients, how do we equate the coefficients? It is m power a and m power b, a plus b, L power minus a minus 3b and plus c, it will be here, t power only minus a because t is not here or here. Now we are equating the coefficients, m is not here. So what will be a plus b? It will be 0, no power on the left side. What is L here? The power of L is 1. So this minus a minus 3b and plus c will be equal to 1. And what is the power of this t? It is minus a only. Okay. So this minus a is equal to this minus 1. So once minus a is minus 1, a is 1. We substitute this a equal to 1 here. This gives b is equal to minus 1. And once we substitute both a and b, here we get c. C is equal to minus 1. So we substitute this a, b and c in this formula. What do we get? That Vc is equal to k times neta by rho into r. So this is the formula for critical velocity. More than critical velocity, we are interested in this k. This k will be equal to Vc rho r divided by neta. And for a particular fluid, for a particular liquid, when we find the value of this k through some pipe of a given radius, the value comes out to be 2000. Remember, this k is also sometimes written as r, or it is called as Reynolds number. Reynolds number. All you have to remember is that whenever the value of Reynolds number is less than 2000, for any liquid, for any fluid, the flow will be streamline or steady. It will be streamline or steady. And when the value of this r is greater than 2000, the flow will be turbulent. At the boundary value, that means that r is equal to 2000, we will attain the critical velocity, up to which the value is steady and beyond which the value is turbulent. So that is a very simple and basic concept about streamline and turbulent flow of liquids. I am once again bringing the pages before your view to have a final look at the topic. Okay, streamline and turbulent flow. We have described it by means of a pipe, by means of a flow of ink, and then we have found the value of the critical velocity by combining these three factors through dimensional formula, and in the end we get this formula. Okay, the value of Reynolds number is 2000. Because it is a number, it doesn't have any units. We have mentioned that for k or r less than 2000, the flow will be streamline or steady, and for value of Reynolds number greater than 2000, the flow of the liquid will be turbulent. That is all.